Greetings, cosmic explorers. Today we embark on a journey that transcends our earthly confines, venturing into the vast, awe-inspiring universe. We'll be setting sail across a cosmic sea, where galaxies twinkle like distant lighthouses, and the mysteries of dark matter lurk in the deep. A journey that spans billions of light years, far beyond our wildest dreams. So, fasten your seatbelts as we voyage to the cosmos, exploring the wonders of the universe and the captivating secrets that it holds. The universe, a cosmic canvas of mind-boggling dimensions, stretches billions of light years across. This vast expanse is a stage for celestial bodies of all sizes, from tiny dust particles to enormous galaxies. But to truly grasp the grandeur of the cosmos, we must delve into the concept of cosmic scales. Imagine, if you will, a realm where galaxies are the basic building blocks. These vast rotating systems, teeming with billions of stars, planets, and other celestial bodies, are spread across the universe like pearls scattered across an infinite ocean. Yet, galaxies are not isolated entities. They often cluster together, forming larger structures known as galaxy clusters, and even larger ones called superclusters. But the universe doesn't stop at 3 dimensions. Theoretical physics postulates the existence of higher dimensions, dimensions beyond our immediate perception. These dimensions, intertwined and compact, could potentially give rise to the strange behaviors we observe in the quantum world and might even hold the key to unifying our understanding of the universe. Our journey across these cosmic scales, from galaxies to superclusters and beyond, might make us feel small and insignificant. Yet it's this very understanding of our cosmic insignificance that makes us truly significant, for it is a testament to our curiosity and our relentless pursuit of knowledge. Our understanding of these cosmic scales gives us a new perspective on our place within it. Galaxies, the universe's majestic cities of stars, are as diverse as they are numerous. Imagine a vast cosmic arena filled with a multitude of galaxies, each with its unique character and history. Spiral galaxies, like our very own Milky Way, elegantly swirl with billions of stars, gas, and dust. They're the cosmic artists painting the universe with their grand, sweeping arms. On the other hand, elliptical galaxies might seem less dramatic, but hold your breath. They're the universe's gentle giants, often holding more stars than their spiral siblings. Their smooth, rounded appearance belies a chaotic past, a testament to their formation through the collision and merger of smaller galaxies. Then there are the irregular galaxies. These galaxies are the cosmic rebels, refusing to fit into any predefined shape. They're often the result of gravitational interactions or even collisions with other galaxies. The formation and evolution of galaxies have profound implications for the universe. They serve as cosmic laboratories, allowing us to understand how matter coalesces under gravity, how stars are born and die, and how the elements necessary for life are synthesized in their fiery crucibles. These celestial cities, each unique and awe-inspiring, paint a beautiful picture of the universe's diversity. As we continue to explore, we uncover more about the mysteries of the cosmos, reminding us that our journey into the universe is far from over. The universe in its grandeur isn't static. It's expanding and at an accelerating pace. This isn't a mere hypothesis, but a well-established fact, backed by compelling evidence. Let's delve into this fascinating aspect of the cosmos. Firstly, we have the concept of redshift. When we observe distant galaxies, we find that the light they emit appears more red than we would expect. This is due to the Doppler effect, where light from objects moving away from us shifts towards the red end of the spectrum. The farther away these galaxies are, the more their light is redshifted, indicating they are moving away from us faster. This is a clear sign of an expanding universe. Secondly, we have the cosmic microwave background radiation. This is a faint glow of heat, left over from the Big Bang, that permeates the entire universe. The uniformity of this radiation in all directions provides further evidence that the universe is expanding evenly in all directions. But what's causing this expansion? Enter dark energy and dark matter. Dark energy, a mysterious force that we know little about, seems to be driving the acceleration of the universe's expansion. Dark matter, while invisible and undetectable by conventional means, exerts gravitational effects that influence the structure and expansion of the universe. This brings us to the Big Bang theory. According to this theory, the universe originated from a singularity, an infinitely small, hot, and dense point, about 13.8 billion years ago. Ever since, the universe has been expanding, evolving, and creating the mind-boggling diversity we see today. The universe's expansion is a testament to its dynamic and ever-evolving nature. Just as life on Earth constantly adapts and evolves, so too does the cosmos, on scales far beyond our wildest dreams. Our search for life extends beyond our solar system, reaching out to the farthest exoplanets. These are planets that orbit a star outside our solar system, and they open up a whole new realm of possibilities in our quest to find life elsewhere in the universe. Let's take a moment to consider the sheer numbers. Astronomers estimate that there could be billions, if not trillions, of exoplanets in our Milky Way galaxy alone. Among these, a significant number are in what scientists call the Goldilocks zone, a habitable area around a star where conditions might just be just right for life to exist. So, what makes a planet habitable? It's not just about being the right distance from a star. The planet needs to have a suitable atmosphere and the potential for liquid water, among other factors. It's a complex puzzle, but one that scientists are eager to solve. Technological advancements in recent years have allowed us to detect and study these exoplanets in greater detail than ever before. From space telescopes like Kepler and TESS, to spectroscopic techniques that analyze light to reveal clues about a planet's atmosphere, we're making strides in this exciting field of research. While we've yet to find life beyond Earth, the search continues, fueled by our insatiable curiosity. Who knows what discoveries await us as we delve deeper into the cosmos, exploring these distant worlds. Our journey through the cosmos today has given us a glimpse into the universe's vastness, diversity, and mysteries. We've traversed the cosmic scales, admired the diversity of galaxies, and peered into the expanding universe. We've even dared to ponder life beyond our planet, and the mysteries of dark matter and dark energy. If this journey has sparked your curiosity, please like, share, and subscribe for more explorations into the unknown. We appreciate your company on this cosmic journey. Until next time, keep exploring and stay curious.